Let's talk about deviation. A deviation is just the distance from the mean. And for our limited purposes right now, we'll get to samples later, but I'm only speaking of populations, and you'll be able to recognize that by the notation. X minus mu will be deviation. So basically, for any given score, I can see what the deviation is. Or another simpler term for deviation is just subtraction. But we really insist on that term of deviation for now. So for instance, if I have a distribution of scores with a mean of 50, and my score happens to be 53, then the deviation is 3. If my score were 45, then the deviation would be -5. Of course, that's a fairly easy concept there, just any score minus the mean. Let's say we start with a following set of n equals 4 scores. And again, for now, just for the sake of simplicity, we're starting off speaking of populations arbitrarily that are labeled by, you can tell by the uppercase N. So in this case, I have 4 scores. They add up to a sum of 12, and so the mean is 3, as you can see. And could I calculate a deviation for each of those scores? Well, sure. If the mean is 3, then 8 is above by 5. The 1 is below by 2. The 3 is even, so there's no deviation there. And of course, 0 is 3 below. And I'm exasperated with this because I do so wish that they would be consistent about listing the numbers in descending order instead of the nearly random order that they have them here. But nonetheless, you'll see that every score can be assigned a deviation. And this is an important thing to notice, that when we add the sum of those deviations, it's always 0, irrespective of how many numbers and irrespective of what the mean is. Any 3 numbers, any 2 numbers, any 26 numbers that you can come up with, if I add the deviations, it will always sum to 0. And that's how you can basically check to make sure the calculation of your deviations is correct. So I want to hit the terms variance and standard deviation here shortly, so that we might sort of get at a mean deviation or a standard deviation or a numerical description of how spread out numbers are above and beyond the range. But as we'll see, we really can't take a mean deviation. And why not? Well, if the sum of all the deviations is 0, what would the mean of the deviations be? 0 divided by 4 is 0. I've got a problem there. It doesn't work. So there has to be a sort of a workaround, as they call it, or a different way of arriving at the solution in order to calculate what we call a standard deviation, which is not just an arbitrary calculation, but something that has some real meaning that we'll get into, of course, more in chapters 5 and 6.